So last time, before we invite the speaker, Professor Lec18, so we learned about the host function of the query optimization. So let me briefly overview of the query processing in relational database management system. When you submit the query like this one, or any other condition. So what happened when you submit this query to your database server? So what happened? So this is the high-level language to access the data, especially for relational database. Use. You will see after graduation when you go through the IT, information technology, or computer science, whether either academia or the industry, you will see a lot of examples that follow this format, like the query language style. Something query. Somebody say MQL or something QL, something QL. However, structured query language is only for relational database model, relational database management system. However, because of the popularity of the structured query language, SQL, so many of the application, even application use the query language style for their interface. Okay, that doesn't mean they use relational model. Instead, they try to get the benefit of using query language. So don't become, for example, I'm going to offer the NoSQL database in 4th semester. NoSQL database is, the big data system nowadays. It's the main trend of the IT. Or even academia, computer science, the big data research and study are very, very important nowadays. In that, the big data system, it is based on the Hadoop. What is a Hadoop? Hadoop is it's a big data system. Okay? Nothing but actually, if you are familiar with the distributed system, this is a distributed system. Okay? Is it operating system? No, it's an application level. Okay? It is based on the Linux. It can be the Windows. You can use the Sun OS. You can use any operating system. And so the Hadoop is coded by Java to support what? Distributed system. Okay? So if you are familiar with the Linux system, even in the Linux system, there are some operating system, some application level operating system to support the distributed system. For example, Fedora, where they support the distributed system. So this is nothing but the distributed system, which is based on HDFS and the MapReduce program. Okay? This is a distributed file system. This is the distributed parallel program. This is the programming. This is a distributed file system. It is actually based on GFS, Google File System. Google developed HDFS. Then, to get the benefit of the distributed system, MapReduce is the program, Java programming, to parallelize the programming. And using this Hadoop big data system, we need to sometimes manage such a data. at the time, many people are familiar with such a select from where style access the data. To access the data in Hadoop, actually you need to use map reduce program. You need to code to access the data. It's very hard, not easy for the beginner. Even the advanced user, it's not easy to code everything. Instead, why don't we make this kind select from where style interface to access the data? Okay, instead of the table name, we can use the from, close, or file name. This one is, instead of column name, most of the big data that you are going to learn, use in the Hadoop system is sometimes comma separate. Or even we can specify that specific data. Okay? So that is used for select, projection. And even there is a condition, so we can use this kind of sequence. That doesn't mean this is based on relational database model. No. This is sometimes NoSQL database. That doesn't mean the anti-SQL. It's not only SQL, but a bunch of other structure. We can accommodate more flexible data structure. Okay? For example, HBase. And Cassandra, I don't know exact spelling. And MongoDB, CoachDB, and so on. More flexible DBMS based on Hadoop system. Okay, so when we submit this query, relational database has their own way to access the data. So this language should be compiled. That is called the interpret. During the interpretation, we'll scan, parse, and validate. Scan means check all the keyword whether they are correct or not. Then parsing is whether syntax is correct. And finally, when you have the permission, whether you use the file when. If they are successful, then query optimizer will find the best path, fastest way to access 3 tables in this example. One, for example. How many different ways to access 3 tables? First, 1, 2, 3. 1, 2, 3. And total 3 factorial. Right? So 6 times. And also, for each table, how many different ways to access each table? We learn 9 different selection ways. Okay? So 9 different selection. 9 different selection. Times, 6 times. Also, when you join table, can you remember the Professor Arif's explanation about the nested loop? Nested loop is one of the ways. Single loop, nested loop, hash join, short merge join. Right? So 4 different ways, 4 different ways. There are many different ways. So we need to find one best path. How can we decide one best path? We are going to use, for each case, like we have 9 different ways, 9 different cost function. Then compute how many, what is the cost of it, and what is the cost of it. And from 1 to 2,000 different ways, compute the cost. And select lowest cost way to access the data. Okay, this is called what? Cost-based optimization. Okay, most popular. Another way of the optimization is rule-based optimization. Rule-based optimization use what? Rules. Okay. Usually 10 to 15 different rules. Fastest way is what? Using primary key. And the slowest way is not slow, but any low priority is linear search or full table scan or brute force way. Okay? Then apply such a rule. highest priority role first to the lowest priority. And that is rule-based. Okay, so that is the cost-based optimization. So we are discussing about how to compute the cost for each case. Okay, and also one more thing. We need to compute all 2,000 different cases. It will take much longer time than you expect. So we don't have to do that. How can we reduce the time to compute the cost? We can narrow down the cases. Obvious case we can throw away. How can we do that? By applying heuristic approach. Okay? The simple rule is the selection condition, like this one, will operate first. Then we can minimize the data. Right? So that is a simple rule. If you can find any operation that can reduce more data, we would apply first. As long as you can keep the meaning of your query, it's fine. So at that time, we need to consider query tree. Query block and make the query tree. Here is the tree. Yes. So we can make the query tree by first apply the one heuristic. So eventually we will have this is optimized. Then if we narrow down the cases, we can apply the cost-based optimization, cost function. So for that cost function, we already check out the selection part. So why don't you see the handout? And so we have the 9, in this case 8, 9, wait, or 8 actually. In this case, we have the 8 different cases. First one, linear search. In case equality condition, we access only one data, that will be B over 2, because it's a binary search, right? But not binary search, it's a pool. If we are lucky, we can get the data from the first block. What does B stand for? What is B in terms of the notation? It's the number of blocks. When we compute the cost means number of blocks equals what? That is a good example of your question. Why do we consider the number of blocks to compute the cost? Right? What is the answer? Why? You want to fail this course? Why? I/O cost is the most expensive one compared to other operations. Okay? Memory access, slow. Okay? Even though you sort the data in the memory, it doesn't take a long time. Okay? So we can even ignore. So we try to count the number of I/O. Okay? Oh, one more thing you need to keep in mind is this is not the exact value. It's the best estimation. Okay? There's no way until you really access the data. It's not possible. It's very hard to know exactly how many I/Os are needed. Okay? This is the best guess, or educated guess, or something nice guess. Okay? Not random guess. So this is the best estimation. So in case we need to access more data based on the like the inequality, we need to access the sometimes entire block at the time as a B. Binary search and primary index, okay, and multiple record, primary index, cluster index. So most popular one is the using secondary index. At this time, what does it stand for? BL1. What is it? Number of first level. L stands for leaf node. Okay? the first node. Okay, why? X means it's a level. Definitely when you have the index, b plus 3 index, like the level 3, so x equals 3, you need to x 1, 2, 3. Always 1, 2, 3, 1, 2, 3. That is the benefit of B3 index, B plus 3 index, especially B plus 3 index. B plus 3 is entirely balanced. Why? B3 index is, there is the upper bound, maximum, 1 through 11. Okay? Sometimes you can get the data from the top, otherwise, yes. This is B3, and B plus 3 is always leaf node. So, this is the, so if you access only one data, that is the x plus s. S is the data block. Okay? However, if you access with the inequality, it will be after that. If you are using the B3 index, you need to up and down. Okay. On the other hand, however, if you are using the B plus 3, you have sibling pointer. So instead of up and down, you can go to next sibling, next sibling. Roughly, average is the B element over 2. And that's the reason it's B element 1 over 2. Also in data block, so on average, is the number of half of the number of 1. Then you have the data. It's not ordered, so it's everywhere. So it's how many times number. Because of this, you need to access same time of that data. Okay, on average. That means when you are using the inequality, it will be considered slower one. If you are sure this is an exact query, equality query, that will be much faster in terms of query optimization, query processing. Okay? That may cause a problem. So even though I'd like to access SSN equal 111, but if you put, there's no high, for example, 999. There's no number higher than 999. Okay? It's a 3-digit. But if you put this one, it will consider this cost function. Okay? And sometimes primary key will not be used because your query optimizer believe the full table scan, linear search is faster. Okay? So you should be careful when you use the inequality. Conjunctive, in case of conjunctive, you need to decompose and select the best. Okay? If you have the composite index for that conjunctive index, which means, for example, E name is SSN and SSN E name plus SSN, then pointer, you can use this index for this. However, if you have an index for each SSN or E name, that doesn't, at the time of this case, will not be considered. That's the selection first function. Next. Oh, we have some example. Okay. We are going to use this database. Okay. It's the same database that we have been used throughout the semester. I believe you almost memorized that this one is a company database. So first, using that company database, how many rows? How many employees? 10,000 employees. Okay? And how many blocks for employees? 2,000 blocks. Which means what is the blocking factor of employee? That is 200. 5. Why? We have 2,000 blocks for 10,000 employees. On average, each block has 5. Okay? Sometimes you may have the less than 5. Sometimes you may have the more than 5, depending on the name or the flexible variable character, not fixed length. Okay? On average, you can get this one, this information. How can you get this information? You need to get the statistical information. You need to run certain program, okay, to get such a statistical information. At the time, you need to check all the rows, all the blocks. No, it will be based on sampling. You can just check 5% of your data. You can just check the sometimes 1%, maybe enough. This is the benefit of the statistics sampling. You can predict, like the presidential campaign. The QNPR is one of the famous organization who provides such a for statistics, like who will be the next president. Do they investigate entire American citizen? Who will be the next president? They will probably select 1,000 people, sometimes less than 1,000 people. How much you support the current government? Then they will they said there's a plus minus 2.5 error margin. What does that mean? That error margin. When you see something statistic from the news, 5% error margin, 2.5% error margin. What does it mean? It's a normal distribution. It's an extreme case. This is only 2.5%. Okay? Plus minus 5%, something like that. So usually it will belong to the middle because it's from normal distribution. Okay? Anyway, this is a statistics you can collect. The next week you will see how to collect such information. It's called analyze. Analyze command. You can run analyze command. Then there's a program that check your database. You can specify 100% entire or only 10% sample. Then we get such a data. If you have the more data, the bigger database you have, the longer time it takes. Okay? That is one common mistake. Sometimes database administrator, from time to time, they rebuild your database. It's called the reorganization. Reorg. What does that mean? Reorganization. We create the database. Why do we need to recreate the database? We already exist. We just recreate the database.
It's badly organized or better structured. We have to create
Better structure, better physical structure. For example, have you ever did the defragmentation for your Windows 95? So Windows ME? What's the benefit of that? We really get the benefit of defrag. I'm not sure, but anyway, they said, the Microsoft said you can get the benefit of the defrag in case what? When? Crash? Actually not crash. When you see the disk map, your data, first part is reserved for operating system, right? Then the other part, application sometimes, like it's a scatter. It's better compact. Why? Because your hard disk drive is anyway the moving forward and backward and rotate your disk and find the data. If the data is separated, so moving forward and get the data and backward, which is definitely slower than continuously. Same idea. So in case your database is scattered a lot. Scattered means your block is separated. Also, index is another big problem. As you have seen in your homework, even though we have the same index key entry, depending on depending on the order of the data index key. Sometimes you can have level 2, sometimes you have level 3. Huge difference, actually. 50%, actually. That's the kind of illusion of the statistics. It's only one level different, but it's a 50% different. Somebody said 50% performance difference, actually not much. But anyway, so in case such a thing, we do better first download, delete, recreate, upload the data. Then we will get the better performance. However, sometimes database administrator forgot to collect new information about statistics. Definitely it will be different, right? So because the level will be changing, okay? So when you recreate, or the from time to time, certain times later, you do better collect the new information. That is a very important thing for database administrator. Some of the DBMS do not have a function to manually collect the information. It's automatic, but as you know, you should not believe the all automatic function in computer, right? So some of the DBMS actually do not support such a manual operation on collecting statistical information. At the time, there is no way, even though I believe this is the best way to access the data, no way to change the past. Okay. So this is an example. Clustering index on salary. We have the clustering index. This is the more information. So clustering index on salary. We have the clustering index. Level, how many level? 3 level. So we have this kind of clustering index data by one to 3 level clustering index on salary. Similarly, secondary index means SSN is not the key. SSN is the key. Here, they create the secondary index, which means it's not ordered data set. So it has the SSN level 4. And secondary index non-key, DNO, it has 2 levels. And leaf node has the full leaf node, and the DNO is a 125 distinct value. 125 department. Okay? And since S is the selectivity, right? So selectivity. S is the selectivity is as a cardinality. How many rows will be written? When you access one block, it will return 80. Okay? Department. Secondary index on sex is the 1 level, and because it's just either male or female, so obviously it needs to either 1 block and how many distinct value? 2. What is the cardinality? How many data will be written for each data? It's roughly half and half. Okay? We don't know whether exact number, but roughly, because it's the best estimation. The query optimizer will use this statistical information for the given query. Actually, this is already converted to the relational algebra